In her session Enterprise Integration with Logic Apps, one of our frequent speakers, Divya Swankar from Microsoft, shares the latest updates and demos to showcase enterprise integration capabilities, including monitoring, SAP integration, and more. Please welcome Divya Swankar.
Good morning. It's great to be back at Integrate and very excited to present you this session. Hopefully by next year we'll be able to do this in person. For today's session, my agenda is pretty simple. I want to showcase some of the capabilities that we've been working this past year, as well as share our plans and roadmap. From day one, our mission is to provide an application platform that enables everyone to be a developer. We try to provide the platform and tools and capabilities so that developers write code only to solve their business problems. We also want to provide simple and reliable ways to optimize the operations and management of your applications. All this is with the goal to enable you to innovate faster and transform your business with growing and ever-changing customer needs and to stay ahead of the competition. Connectors are one of the biggest value props of our platform and enable developers to write low-code applications. In a non-logic app world, if you have to write an application that connects to multiple services and applications, you would have to start from scratch. The first step would be to figure out if there are any APIs or SDKs available for those services. Is there enough documentation or help available to use those APIs? The next step would be to figure out what kind of auth will be required. If it's based on OAuth, you would have to complete even more steps such as creation and registration of your developer app, and of course figure out the whole OAuth dance and token management. All of this is huge effort that is proportional to the number of services you connect to, and this number is quite large for most organizations. And it doesn't stop there. The APIs you are using can change and you are responsible for keeping them up to date. In this entire process, you've not even started with the business problem. With Logic Apps, this is a completely different story. You start with what you want to connect to and you pick one of the pre-built connectors from the list of 450 plus connectors that we have and start creating your application. Regardless of the service that you're using, regardless of the type of the authentication, the type of the APIs, your time to integrate to these services is nearly constant. And if we do not have an out-of-box connector, we provide simple and intuitive way for you to create your own custom connectors that share similar benefits. These connectors unlock scenarios across multiple industry verticals. Enterprise applications like ERP systems, CRM apps, databases are used across all industry segments. We also provide connectors for various standards and protocols specific to EDI as well as industry segments like healthcare and SWIFT for financial payments. We've been very busy this past year. You've all heard and seen a lot about standard logic apps, which unlocks a lot of use cases and industry verticals by enabling you to run your applications and connectors anywhere. Along with that, here is a list of few more improvements that have happened along the way. Managed identity, which is the preferred and recommended way to authenticate to Azure services, has been added for a lot of connectors. Earlier this month, we've also released EIP tools for VS 2019. These tools include the visual mapper to create XSLT-based maps for XML transformations, as well as schemas for flat file processing. Standard Logic Apps also comes with a new connector model that's built into the runtime and provides better performance and more control. We are rapidly adding more built-in connectors so that you can use these connectors in your portable scenarios. In the SAP connector, we have added a bunch of new capabilities in the last year. Some of these include the support of flat file iDocs. You can now send and receive iDocs in flat file format using the connector. We've also added the support for plain XML format so that customers do not have to educate themselves with Microsoft specific schema for iDocs. This would also help customers who are moving to Logic Apps from other platforms. On the RFC side, we have added the support for stateful RFCs and transactions, which I'll be covering later in my demo. In the ICE version of the SAP connector, we have added the support for certificates. So now you can use SNC for certificate-based authentication in ICE as well. Let's see some of the stuff in action, starting with the demo on new capabilities in standard logic apps. In this demo, I want to showcase some of the newly released enterprise capabilities that come with the standard logic apps. Along with these enterprise capabilities comes a new connector model built into the runtime to provide high performance and scale. Some of the connectors that have already been built using this new model include Service Bus, Event Hub, MQ, XML and Liquid Operations, Azure Blob, and many others. Alright, so what I have here is an empty project that I've created from the scratch in VS Code locally. And I want to start creating my first workflow here, and I'll start with the trigger, and let's go with the simple request trigger. I will save my logic app after that. So as a next step, I want to do XML transformation. I want to use this logic app to transform my XML payload based on an XSLT map. I have already created the map using Visual Mapper that is now part of EIP tools and available on VS 2019. Where do I upload this map? I'm going to use the artifacts folder here in my local file system and drop the map. As you can see, the map has been copied here, and this is my XSLT based map. I have also copied a second map here to do further transformation of my XML payload to convert it to JSON in the specific format that is of interest. So now I have maps both for XML and Liquid transformation. Let's go back to the logic app. Let's add the next step in the workflow to do XML transformation for the payload that is being received through an external request. I'm going to use XML operations category here and you select transform XML. The payload is coming from the request trigger, and the map is something that we added into the artifacts folder. As you can see, the drop down has automatically picked only the XSLT map from the list of maps I have added. We select the map and then save this logic app. I'm also going to add the next step here, which is to do the XML transformation using Liquid action. This step is going to convert the XML I have to the JSON payload. And to do so, I'm going to use the output from my previous step and apply the map that I've already created here. Again, the drop down has filtered and only showing the Liquid map to be used. Save the logic app. Now let's execute this logic app and see what happens. To trigger this workflow, I have copied the callback URL and I am using Postman to trigger this logic app run. Let's look at the output of the run. Here is the input that I had sent through Postman. The XML payload that I have sent includes both attributes and elements, and the map, XML map, converts all the attributes to element. And as we can see from the output of this step, the operation was successful. Finally, in the third step, we have converted the XML into the JSON. The key thing that I want to highlight so far is that in the entire demo, I have not even mentioned integration account. And that is the biggest change here, is that we have decoupled all the transformation actions, all the transformation activities from integration account. You can use these actions locally or on cloud without having the need to use integration account. Now for the next scenario, I want to make this logic app do a bit more, and therefore I've added a couple of more actions to call an Azure function, to call an external endpoint through HTTP connector, and send some of the data to different services like Azure Event Hub, Azure Service Bus, and even to a third-party SaaS service like Dropbox. I'm going to publish this Logic app to cloud, and in that process, I'm also going to enable this Logic app to push telemetry to App Insights. Forward a bit, and here is my Logic app that's been deployed to Azure and is now running in cloud. It also has App Insights enabled. I have exposed the Logic app that I just published to Azure as an API in APIM. Now I want to trigger this Logic app from the APIM, and I'm going to use the test setting in APIM to trigger my workflow. The Logic app has been successfully triggered via APIM. Now let's look at how we can monitor this Logic app using Application Insights. One of the cool capabilities that Application Insights provides is Application Map. Let's look at what the application map looks like for the workflow that we just triggered. If you recall the workflow that we had created, we added a bunch of services into that workflow. We were calling a Logic app, we were calling a function app, and we were also calling a bunch of external services. So this is how the application map for the Logic app looks like. The application map here shows the full application topology and call graph across all the components and the external dependencies in your application. The green nodes here represent the components in your application, while the leaf nodes are the external dependencies such as SQL, Event Hub, Dropbox, etc. You can click on any of the components here to see the insights and more performance details. And this includes not just Logic app, but any of the other services in this dependency graph that have been called as part of this workflow execution. You can do further analysis on the APIM, or you can even look at the function app that was invoked from Logic app or the other Logic app. So let's look into one of these nodes to see the details. As you can see, when I click the Logic app, I can see the details by requests. We can also see the requests that originated from this workflow, and we can further click into investigate performance to see more details about the time it took for each of those requests, as well as all the requests that happened as part of the execution of that workflow. So as you go down in the operation name, you can see all the action executions that happened as part of the execution of this Logic app. The HTTP node here shows you all the requests that were made from the Logic apps inside your application. As you can see, we are using 3 different connectors here: Service Bus, SAP, Dropbox, and all these requests are being captured via this node. So via this application map, and by going into the details of each of these nodes, you can do a very deep analysis of the performance characteristics of your application, as well as any failures or issues that may happen in your application. So to quickly recap, data transformation in standard Logic apps can be done locally as well as on cloud without the need for integration account. We acknowledge that customers most of the times use Logic apps along with other Azure services. Application Map enables you to get that single pane of view of the entire dependency graph across all the Azure services in your application. With standard Logic apps, you can use Application Map as well as other App Insights features to monitor your Logic apps. Let's take a look at another demo that highlights some of the more new and advanced enterprise capabilities that have been added recently in the product. In this demo, I would like to start with OData connector that is currently in private preview. If you are interested to sign up for the private preview, I will be sharing link later in my slides. There are multiple actions available as part of this connector, which can be used either to read data from your application or to write or update the data into your application. So I'm going to start with the action to read OData entity. I had already created the connection Therefore, all I need to provide is the URI to my service. In my case, I want to use this OData connector to query data from my SAP system. The OData service that I'm using sits behind an APIM and exposes the SAP data as RESTful APIs. The next step is to pick the entity name that you want to query. So in this case, I'm going to use product set entity. I also need to provide the product ID that I want to query. Now this step is going to query one record from my SAP system. If you want to query all the product set entities in the SAP system, I can also use another action that brings back all the entities. Instead of bringing back all the entities, there are also filters available which can be used to further filter the data based on the conditions that you want to use. So in my case, I'm going to use the top filter, which is going to return the top 5 records. I ran the logic app and now I have the run available here. The first step to read OData entity returns me the single record that I mentioned using the product ID. The second step, which was to read the collection of entities, returns the top 5 entities, the top 5 records from the product set table. Next, I would like to show how you can use managed identity to authenticate with Azure services using logic apps. Managed identity eliminates the need for developers to manage credentials. You can think of managed identity as a special type of service principal that can only be used for Azure services. So let's further extend this scenario and send the data that we queried from SAP system using OData connector into one of the Azure services such as Azure Data Lake. But before we do that, we need to enable managed identity of this logic app. This can be done by going into the Identity tab and toggling the status of your system assigned identity to on. This generates the unique object ID for your logic app. You could also use user assigned identity. Before we can use our logic app to authenticate with managed identity, we also need to grant access to the managed identity in the target resource, which is our Azure Data Lake instance in this case. To do so, we go into the access control policies of that resource and add logic app managed identity. Next, we are going to use the upload file action of the Azure Data Lake connector to upload the data that we have queried in the previous steps. We have a successful run here. The upload file operation to Azure Data Lake was successful, and at runtime, the managed identity of the logic app was used for the authentication to the Azure Data Lake instance. When it comes to SAP, we've added a lot of features, both to improve the usability as well as to support advanced scenarios. The number of actions to support these scenarios have been growing, and we have therefore done some work to reorganize and categorize them better so that it's easier to discover them as well as to use them for your SAP scenarios. I'm going to very quickly walk through some of the advanced patterns that are being enabled by these actions in the next couple of minutes. So the first one I have here is around stateful RFCs. We've had the support for stateful BAPIs for quite some time, which allows you to group together BAPIs as a logical unit of work. The same concept applies to RFCs as well, where you can group together RFCs and process them in a session in a stateful manner. So in this case, as you can see, the first step here would be to create the session and then make calls to one or more RFCs within the context of the session. When you're done with the RFC calls, at the end, you close the session. So this is very useful for some of the advanced use cases with SAP, such as lean order processing, where you need to chain multiple RFCs and use the output from one RFC as an input to the other one. Let's take a look at the second pattern. In this case, we are using action to create an RFC transaction and then adding one or more RFC to the transaction. Finally, we are committing the transaction. The commit transaction step basically commits all the RFCs that you've added to the transaction in one go. So instead of making multiple RFC calls to your SAP system, you have now grouped together one or more RFCs into a single call made to the SAP system. When you create the transaction, all the RFCs that you're adding later to that transaction use the transaction identifier created in the first step. This is the context. This is the common context shared across all the RFCs that get added to the transaction. Finally, when you commit the transaction, you use the same transaction ID that was created in the first step. When you look at the run for this workflow, the commit transaction basically lists out all the RFCs that were added to the transaction and were committed in this single step. The third scenario I have here is around testing and troubleshooting your application. One of the common tasks for a developer when sending data to SAP is to confirm if everything was successfully written to the SAP tables. A lot of times, Logic App developer either does not have the expertise or does not have the access to the SAP systems where they are sending data. In most cases, they have to work with SAP basis experts to figure out if end-to-end things worked as expected. We have tried to make this process more efficient by adding actions that allow you to check the status of the data of the transactions that you send to the SAP system. We've also added actions to read the SAP table to further get into the details if something went wrong. So the first step I have here is to send IDOC to SAP. And I'm using plain XML instead of the complex Microsoft specific namespace based XML to send data, to send IDOC to SAP here. Once the IDOC has been sent to SAP, then we retrieve the IDOC numbers for that transaction and use the action to check the status of each of the IDOCs that were part of that payload. After getting the IDOC number, we are pulling more details about the transaction from the SAP table. If you look at the runs for this workflow, the step to send the IDOC was successfully completed. In the next step, we get the IDOC list for the transaction. So there is a single IDOC that was part of that transaction. When we check the status of that IDOC, it returns a status code, which we do not know what it means. And so as a next step, you can read more details around what the status means and what happened to the state of that IDOC. So in this case, we know that the IDOC that we had submitted to SAP, while the action itself was successful, it was added to SAP but with some errors. To reach to this point also, before, the Logic App developer was required to have access to the SAP system and was required to understand how to figure this out. But now from the Logic App itself, the developer knows the status of the transaction and can now work by themselves or with their SAP experts to further troubleshoot this error. All right. So for this one, I want to make a quick note about the sign up link that has been posted in the slides. The OData connector is in private preview, so you would have to register with us so that we can give you access. If you are interested in trying out this connector, please fill the form and I'll get back to you. Here's a list of some of the things that is planned for short term that you can expect to release in the next couple of months. We are adding more built-in connectors to standard Logic apps. We are also considering some of the file-based connectors to be released as built-in ones. Let us know what connectors are important for you to build your portable applications. On the MSI sides, we are adding more connectors to support MSI. This will also be extended to the connectors in standard logic apps. We are also going to enable user-assigned identity for logic apps. When it comes to API connections, today when you use API connections and authenticate, you need to provide credentials in the connection itself. This means that every time the credentials are updated, the connections need to be redeployed. We plan to integrate Key Vault with API connections so that you can provide your credentials to the API connections through Key Vault reference. This will enable you to centralize the management of your secrets as well as simplify DevOps for API connections. What should we invest in? This is a question we ask ourselves all the time. There is only so much we can do, and therefore it's about doing what matters the most. And we need your help to figure this out. We know that there are still many enterprise applications for which we do not have out-of-box connectors. What does your IT environment look like, and where do you think logic apps can help you integrate with those applications? Should we write more connectors for ERP applications or CRM applications, blockchain, healthcare, and so on? Where are you now, and what is your cloud migration strategy? What connectors we can build to help you with your long-term goals? Monitoring is so crucial for business applications. We know we can do more here. What do you need from us? Do you need better business tracking, better management capabilities, or something else? As we think about our long-term goals, we wonder if customers would like to open source these connectors. Let us know if that's important for you and why. Is it because this gives you flexibility and there is no vendor lock-in? Or do you also see yourself contributing to the connector ecosystem? Dapr is the open source distributed application runtime, which provides application integration through bindings. Would you use Dapr bindings if they were available from logic apps? And the list goes on, so let us know what is important for you. We are in this together. Digital transformation is different for everyone. Each customer is on their own journey, and our mission is to be a part of their journey with incremental steps towards the long-term goal. We want to empower customers to unlock the business value and accelerate innovation. And we want to do this for every organization, from large customers to startups to family-run businesses. This brings us to the end of my session. I hope this was a good use of your time. I want to express my gratitude, and I look forward to your feedback and in-person conference next year. And one last thing, we would really appreciate your feedback. I have a link here with few questions. Hopefully they should not take a lot of your time, and we would really appreciate feedback from you. Thank you so much.
Covey.co